Hi, welcome back. We're doing example 2 from chapter 4, section 2, relations and functions. So we're going to get into this idea of domain and range, finding the domain and range of a relation. Well, those are vocabulary words. Those are maybe new words to you. So let me first describe what the domain and range are going to be. I'm not going to give a real technical answer right now. To be honest, the study of relations and functions and their domain and range, and whether it's one-to-one or onto, there's a lot of information that goes in there. So we have to take it like a little bit at a time. So I'm going to kind of introduce it a little easy, and as we get better at it, we'll really try to pick up the details and pick up some of the nuances. So I'm acknowledging the fact that I'm going to kind of like leave out some of the information at first, but we will definitely be getting into the details as we go through chapter 4 and even chapter 5. Okay, so let's go back. What do I mean by domain and range? Well, the domain, one way to describe the domain is the set. And remember I said in the last video, a set is a collection of all of the input values, where the range is the set of the output values. Now, this is a little tricky to talk about this when we're comparing this to a relation. It's going to mean more down the line when we talk about the functions, when relations become functions. But when we talk about input, we're talking about like the thing that comes first. For the previous video, we had sets of ordered pairs. So we had the first number paired up with the second number. For the table, we had x's and y's, and on the graph, we had x values and y values. So we saw that. So another way to think about the domain now would be the x values. And of course, the range would be the y values. Now, I got to be honest with you, that's a little misleading because you don't always have to use x and y for relations and functions. One of the examples I talked about is that if you know what the things represent, then you can use letters that, like if one of them is time, you can use t. You don't have to use x. But I think we're getting kind of used to the idea that we have x paired up with a y. So we know what the x values and the y values are. Okay? There's two things that could happen. All right? You could have finite or infinite domains or ranges. I'll say and or ranges. So what does that mean? Well, if you think of the first number as the input, the x, and the second number as the output of the y, you could have something where you have only a few pairs of numbers. Maybe you even have like 100, but still you can count to 100. Finite means you can count them. Sometimes there's an infinite number of them, and I cannot count them. So as soon as you think you've got them all, you're going to find another one. And as soon as you find that one, you're going to find more. So you're never really ever going to stop. And I'm going to make an audible call right now. To find the domain and range of this, I think it'd be better if I skipped ahead to another example. Then I'm going to come back to this one, okay? So just hold that thought. I will put this back. So for the next two examples, so we're going to find the domain and the range of this. So for the mapping diagram, remember the mapping diagram represents the first numbers in each pair, and this box represents the first numbers, and this box represents the second numbers. So for the mapping diagram, this represents the domain, and this represents the range. So how do I write it? I write D for domain, use a colon, And you don't have to be perfect with this, but I'm going to draw that set bracket, and I'm going to list these numbers. I'm going to list 1, 2, 5, and 6. Now, a couple things. The order doesn't matter. Does not matter. So if you wrote 5, 2, 6, 1, that's good. You just have to have those numbers in there in any order that you want. However, one thing, no repeats. So I've only got 1, 2, 5, and 6 in there, and I don't have anything doubled up. So I don't have 1, 1, 2, 5, 6. So if you already have it in there, it's in there. You don't have to write it again. For the range, I do kind of the same thing. Use an R with a colon, draw my set bracket, and then my numbers here for the range, -4, -1, 0. Again, the order doesn't matter, and there's no repeats. Okay? And this is what I would call a finite domain and range, because I can count. There's 4 of them in here, and there's 3 of them in there. Moving on to this problem, scoot that up so you can see it. So now I'm given this relation as a table. So my domain is going to be my x values, 1, 4, 8. And again, the order doesn't matter. If you want to write 4, 8, 1 or 8, 4, 1 or 4, 1, 8, it's all good. It's just easy to write them as they are. The range, now pay real close attention to this, is going to be 1, 4, 1. But wait, I already have the number 1 in there. So again, no repeats. So if you wrote, excuse me, if you wrote 1, 4, 1, then that's going to be wrong. Don't put that in there. Okay, so again, pause it, rewind it, do what you need to, if that makes sense. I'm going to go back to the sheet that I just had, because both the ones we just did were finite domains and ranges. You can count them. There's only a few numbers in here. This one is tricky. You see how this is continuous? There's that word from last week. Continuous means I'm going to include all of the numbers from 1 to 3. So for my domain, I have all of the numbers from 1 to 3. And I'll say inclusive, which means I include the 1 and the 3. Now you're probably thinking, well, what's the big deal? So you got 1, 2, and 3. But there's numbers between the 1 and the 2. So here's another point, and here's one of the points, and here's one of the points. But do you see that red line segment that goes between it? That means that you also have 1.5, which gives 2.5. And you also have 2.36. You have all of these numbers that are between 1 and 3, all of them. So there's no way that I'm going to list them. So how do I write this? I choose the smallest x value that I have, which is the number 1, the biggest x value, which is 3, and watch me because I'm going to put some stuff between these. And I say that my x values are between those two numbers. So 1 is less than or equal to all my numbers, which is less than or equal, which all these numbers are less than or equal to 3. So this is what I call my lower boundary. This is what I call my upper boundary. And all the domain values are all these numbers between 1 and 3. This is really hard to wrap our head around. And honestly, I spend a lot of time answering questions about this in class, because, and this goes back to the idea of continuous, which I know is a difficult question, difficult concept. But there's an infinite number of numbers, values, between any two numbers that you pick. You can always find another one just by dividing by 2, or dividing by 7, or dividing by 1,000,000. That keeps splitting it into smaller and smaller numbers. Most of the time, we can just divide it by 2 and find a number that's between them. excuse me, I'm going to have to get a drink of water. For the range is going to be all of the numbers from, what's the smallest y value? 2, up to the biggest y value, which is 4. So from 2 to 4, and one more time I'm going to say inclusive, which means I'm going to include the 2 and the 4. All right? So how do I write that? I write the smallest number, 2. I write the biggest number, 4. And I put less than or equal to y less than or equal to. So this is saying that 2 is less than or equal to the y values, and all the y values are less than or equal to the 4. I know that that is tricky, so rewind that and watch that over again. We'll do more examples when I get to the guided practice problems later.